Welcome everyone to this webinar on the importance of software security assurance in industrial control system applications. I'm Bob Krigler. I'm on staff at ISCI, the ISA Security Compliance Institute. We are very fortunate to have John Cusimano, Ed Crawford, and Graham speak with us today. John is Director of Exeda's Security Services Division. Previously, he led market development for Siemens process automation and safety products. John is a recognized process automation safety and security expert with more than 20 years experience. Ed leads the team at Chevron's energy technology company, responsible for the delivery of process control network security solutions that are a major component used to secure process automation systems across the enterprise. He has a professional certification in cybersecurity, CISSP. Ed is a voting member of ISA 99 and Vice Chairman of the ISA Security Compliance Institute. Graham is a Principal Systems Architect at Yokogawa Electric. In his 30-year career, he spent the last 15 years in industrial cybersecurity. He is co-chair of the International Group for Industrial Control Systems Joint Working Group and a member of ISA 99. So I'd like to start off the webinar with a quick poll to see who's on. You should see a window where you can identify yourself as an asset owner operator, automation system supplier, system integrator, or the other choices there. Great. And it looks like about a quarter of the people are consultants, about a quarter are owner-operators, and a mix of other automation suppliers, system integrators, and other. So I'm going to close the poll. Okay. And I'd like to turn it over to John.
All right, thank you, Bob. Can you hear me okay?
Yep.
Great, thank you, Bob. Good morning, everybody. As Bob said, my name's John Cusimano. I'm with Exeda. And I want to start off kick off this webinar talking about what is software security assurance and why is it important. So we are talking today about the importance of software security assurance as it relates to control system applications. The topic, or the concept of software security assurance, is not new. It's been around for at least a couple decades. And it's defined as the process of ensuring that software has been designed to operate at a level of security that's consistent with the potential harm that could result if that software did not operate correctly. In other words, that could result from the loss, the inaccuracy, the alteration, the unavailability, or misuse of that software. So it's a very important concept because if software is used in many life-critical, safety-critical applications, you're all familiar with flying, I'm sure, and know that there's an awful lot of software running in modern airplanes, from flight controls systems to the software that's used throughout the aircraft, and of course in traffic control, air traffic control. Also in medical devices, there's a life-critical or safety-critical software running in medical devices such as life support systems and dialysis machines and so on. Of course, in the field of nuclear engineering, and even in recreational applications such as ski lifts and amusement park rides, there's a lot of software that is running in life-critical or safety-critical applications. Also in transportation, particularly in the rail industry. In the automobiles that we're driving, now many automobiles have drive-by-wire and other technology where software-based components are responsible for many of the critical parts of the automobile. And last but not least, the field that we're all involved in, industrial automation. The industrial control systems that are running today's plants are heavily software-based, and the risk or the potential for harm if these systems do not operate correctly can be very significant in some cases. So we have to treat, and we do as an industry, we do treat the software that's used in these systems as life critical or safety critical. But a lot has changed in the last few years with regards to security, and it's not good enough now to just look at software from a safety standpoint and the bugs that might exist in that product that would allow the software to have some systematic faults, to do something unexpected. We also have to look at those that might be intentionally trying to misuse the software to try to gain access, to try to elevate their privilege, or to try to do something to force a condition with that software that was not thought about by the designers. Fortunately, a lot of the techniques used to write safe or safety critical code and the techniques to write secure code overlap quite a bit. But the discipline of making sure that the software is properly designed for both safety and security is very important, and it's an effort that has to be planned and followed through from throughout the life cycle of any software product. There unfortunately have been many different examples of software-related incidents with SCADA systems that have caused various types of damage or even injury. Just a few examples here, and there's many more. This first one has probably happened many times, where a software vendor's patch actually, by implementing it, whether it's a security patch or a new feature or function, actually crashes the system that it was intended to improve. So there's actually many examples of those cases where the software, for one reason or another, was not properly tested or tested for that particular application. There's also been several different examples or cases where software failures have caused power outages with electric utilities. There's also been cases where software failures have caused issues with water and wastewater systems, with even cases where a software glitch caused a water main break. And there have been several examples of cases where software failures led to issues with pipelines. There's one example here of a case where it impacted a dam system and drained an entire lake because of a failure with the gates on a dam. There's been cases where SCADA systems software have led to problems with automobile tunnels because of the problems with the ventilation systems. Cases that software has been linked to crashes of aircraft, and cases where, as I mentioned before, software errors have been responsible for or participated in problems with gas leaks. So there are numerous examples. These few here come from the Repository of Industrial Security Incidents database, and there are unfortunately many more, which brings us to this quote that we put in the presentation with permission granted from Mark Weatherford, who at the time was VP and Chief Security Officer for NERC, He's now moved on. He's with DHS. But I saw him not that long ago, and in a conversation with him, I think he still stands behind what he said a few years ago, which is that in this case he was responding to Stuxnet, and he was commenting that the industry needs to demand higher quality software that's free from defects, and that the companies who produce products and write code for industrial automation applications need to continue to mature their development processes to be focused on security. And I think this is one of the well-understood outcomes or responses from industry related to Stuxnet and other viruses that we've seen that are focused on industrial control systems is that the manufacturers need to pay more attention to software security assurance. But it's not just the automation suppliers, of course, that bear that responsibility. There are multiple layers of responsibility, if you will, when it comes to securing our industrial control systems. The ultimate responsibility lies with the end user of these systems. They need to make sure that their facilities are following good security management practices throughout the life cycle of the facility and the life cycle of the control system in that facility. Those that integrate these systems, whether that be the end user or a third party or the automation supplier, they need to be following good system engineering practices for security and make sure that they're using qualified personnel. The supplier of the system, the automation supplier, they need to focus on making sure that the products that they're providing, the products and the systems they're providing, have followed good software development practices for security, and they're following good practices throughout the life cycle of their platforms, and of course have the proper security features that have been tested in. So we're going to focus today on, because we're talking about software security assurance, we're going to be focusing on the automation suppliers, those that supply the software that we're talking about. And the suppliers need to be positioned to support their requirements in a number of different ways. The software development lifecycle is key, so often called the SDL. Making sure that security is part of the software development lifecycle, that it's been properly tested, certified if applicable, and the source code has been validated and so on. Suppliers also need to, if they are providing turnkey systems or engineered systems, they also have to look at their project execution practices, everything from factory acceptance test and security site acceptance test, FAT and SAT, to make sure that the security features and functionality have been properly implemented and tested at the system level. And lastly, suppliers also need to be responsible for security throughout the lifetime or the life cycle of the systems that they're providing. So things like managing patches, security patches, and validating patches, providing their own security updates for their products, and helping their end users mitigate vulnerabilities as they're discovered. So there are a lot of responsibilities there for the automation suppliers. And that's why we are talking about software security assurance as an engineering discipline, because there's a lot of good information out there to help companies that have this responsibility properly design and effectively build security into their products and systems and practices. A few key objectives or tenets of software security assurance. The first three, I'm sure everyone has heard about: confidentiality, integrity, and availability. The CIA triad, it's often referred to as a concept from IT security that's been around for at least 20 years. That says that the three main objectives for security have to focus on protecting confidentiality of information from unauthorized disclosure, integrity of information to make sure it has not been changed or modified or tampered with, and availability of information and the services that provide that information. So CIA certainly applies very well to software security assurance, making sure that code has been designed to protect confidentiality, has been protected against unauthorized changes, and is available to perform its function. A few other objectives that are also very important that relate to software security assurance. One is authenticity or authentication, making sure that the identity of other software components or actual human users have been verified. Authorization, having to do with making sure that once a component or a user has been authenticated, that their privileges are properly restricted to only the privileges they are supposed to be allowed to have. So those two relate to the what we often talk about as the AAA components of access control: authentication, authorization, and accessibility. But lastly, here we have non-repudiation as the last major objective, and that's making sure that there is an audit trail throughout the system to track the operation, particularly of authorized and authenticated users. There are, of course, many risks to software security assurance that make it difficult, and unfortunately more and more difficult as the size and complexity of our software continues to grow. Certainly the software, just the amount of software in an industrial control system today versus 20 years ago is staggering. And that makes the work for the automation suppliers to secure that code much more difficult and complex. So the size and complexity of software certainly makes it challenging. Also the fact that it's very commonplace now to outsource software modules and software development. And unfortunately, in many cases, that software supply chain may be unvetted, or we need to check the security of not only the code that we're writing, but the code that we're purchasing and integrating into our systems. To add to that difficulty, attacks are becoming more sophisticated, but at the same time, there are also a number of tools available on the internet for relatively inexperienced hackers to get their hands on sophisticated exploits. So while the attacks are becoming more sophisticated, the ease of gaining access to those exploits is reducing, or it's getting easier. And probably the last important challenge for software security assurance is legacy code. The systems that, as I've mentioned a few times, the systems that we're using in industrial control applications have a legacy, most of them dating back 10, 15, 20 years. And with that comes the code that has been used in these systems, even though the systems may have gone through several different generations or upgrades over the years. There's often always pockets of legacy code that makes it challenging for system suppliers to make sure that not only their new code is secure, but their existing code is as well. But like I said, fortunately there are some very good resources out there to handle, to put a process around making sure that software has been designed securely and has been tested for security. Few key ones to mention, though this is not necessarily an all-inclusive list, but some key resources to talk about is the Microsoft Security Development Lifecycle. Microsoft has been publishing effectively their lessons learned on writing secure code and developing, having a secure development lifecycle since the early 2000s in a couple of textbooks and also on a website. The Microsoft SDL website has both information as well as free tools that can be downloaded for developers to use for things like threat modeling, for example. Also, there's a program called Build Security In that's sponsored by the Department of Homeland Security. And there's a website link there where there's, again, numerous articles and information and tools for building security into code. And a related textbook from Gary McGraw is called Software Security Building Security In. And last, there's also some more free information available from joint effort between Department of Homeland Security and Department of Defense through the Data and Analysis Center for Software, or DACS, called Enhancing the Development Lifecycle to Produce Secure Software. And there's a link to that as well. So all three of these resources, and as I said, there are many more, talk about the software security assurance in general. This is not unique, of course, to the industrial control system applications, but talk about general good practices and principles for writing secure code. And these do apply to industrial control applications, but it is important to have some information that is unique for our industry, and we will talk about that as we get into the details of what ISA Secure is doing. But one last thing about incorporating security into the software development lifecycle, regardless of which of those texts you read, they all generally talk about some of the same things, and that is that if you want secure code, you have to plan it and follow a life cycle process to make sure that starting all the way with requirements through coding and testing and release of that product, that security has been part of that process. So you may be familiar with this type of development lifecycle model, often called a V model. It doesn't matter which model you use. The concept here is that when we design a product, we write requirements, we do high-level design, we do detailed specifications, we code, then we test those units, then we integrate and test, and finally release the product. When we want to integrate security into our practices, there are a number of different additional steps or enhancements to the steps that need to be taken into account. Starting with training the developers to make sure they know how to write secure code, to documenting security requirements from the beginning, to thinking about security when designing the high-level architecture, to security risk assessment and threat modeling of that high-level design, to making sure that developers are using good secure coding guidelines when writing their actual code, and then checking that with security code reviews, peer reviews, as well as tools like static analysis tools that will find use of banned functions and other bad programming techniques, to security integration testing and validation testing to make sure that the security requirements have actually been implemented, and lastly, that manufacturers have a security response planning and execution so that if a security flaw does get released to the field, that there's a process to handle that. So those are the general information that would come from any of those different lifecycle models. So lastly, before I turn it over to Ed to talk about the ISA Secure program, just to wrap up this section on software security assurance, talk about why this is important and the justification for it. Following good secure coding practices and security development lifecycle will ultimately reduce support costs for the manufacturer. So while it may add more time and effort to the process, most manufacturers that have adopted a security development lifecycle have reported that in the long run it is saving them money in terms of reducing support costs and catching those vulnerabilities before they get into the field, where they obviously are much more costly. Reducing loss of revenue and reputation due to any kind of security breach ultimately getting released, of course, is justification alone. ensuring compliance with government or industry regulations that would be applicable, and being able to get a product certified, of course, is also justification for security. Enhancing the credibility of the company and the development teams is a benefit of following a secure coding practices or security development lifecycle. And of course, reducing the number and the severity of security, or the depth of security patches. And lastly, improving overall security quality or software quality. So there are a lot of benefits to manufacturers in implementing a secure development lifecycle. And so now I'm going to turn it over to Ed Crawford, who's going to talk about ISA Secure. And
all right. Thank you, John. As John mentioned, I want to give you a brief overview of the ISA Security Compliance Institute, or ISCI, and you'll hear us refer to it as ISCI, and how that relates to the Security Development Lifecycle Certification Program for industrial control system suppliers. First of all, ISCI is an organization that's a consortium of asset owners, suppliers, industry organizations. It was formed in 2007, and it is part of the ISA Automation Standards Compliance Institute, or ASCII. The mission of ISCI is to establish a well-engineered set of specifications and processes for the testing and certification of control system products. It is aligned with ISA 99. So ISA 99 provides the security specifications, and then ISCI turns that into specifications that can be certified by a certification lab. The purpose of it is to decrease the time, cost, and risk of developing, acquiring, and deploying control systems by establishing the collaborative industry-based program among asset owners, suppliers, and other stakeholders. The stakeholders are also involved in ISA 99 in the development of the standards. And part of this alignment with ISA 99 includes feedback from ISCI to ISA 99 on things that we find in the implementation of the certification process for improvement, continuous improvement back in the original 99 specs. The membership is made up of both asset owners, automation suppliers, and as I mentioned, we do have an ISA 99 liaison, Eric Kossman, who is also with an asset owner company. So it is an overall international organization. We have strategic membership levels, technical membership levels, and informational membership levels. So you can come in and join and participate at multiple levels. We do have an ISA Secure logo that will be stamped onto the products and the processes and procedures of certified supplier solutions. The overall certification program is structured. It's auditable, so we have to follow the ANSI procedures as part of our development processes. And part of the certification processes. And it has the assurance that automation product systems and suppliers will meet an industry-recognized baseline for cybersecurity. I do want to point out it's similar to SIL levels or safety integrity level certification under ISO IEC 61508 if you're familiar with the SIL certification process. It is an internationally accredited program under ANSI A-Class. That's the A-Class logo indicates that both the program and the certification labs are independently accredited under that program, which ensures impartiality and independence of certification bodies. and it ensures that the process that we follow to do this is open, fair, credible, and robust. So how does a supplier go through and get an approval under this certification? They submit the device to the chartered lab, and then the chartered lab completes a three-part assessment, which includes a functionality or functional security assessment. Then they do a communication robustness test, which is done with an ISKI-approved test tool, this to find out if there are any vulnerabilities with malformed packets and such. Then finally, it goes through an audit on the software development practices. And that's what we were talking about today, is the software development life cycle. In order to attain this, it does an audit on the processes and procedures. And in many cases, it might cause an automation supplier to change the process that they use in developing their software to assure that we have a security compliance throughout the process. And then once it gets through the chartered lab will issue a final assessment and certification that will show the process it went through and the steps that were passed in the audit. So, as an end user, why would we be interested in the ISA Secure certification for our products? Well, and why would we be a member? We'll talk more about the benefits of the certified products, but definitely as a member of ISCI, we get to participate in defining and updating and approving what goes into the certifications to make sure it meets our requirements from an end user perspective. We do know that we have critical infrastructure requirements to lock down our systems, and as much of that as we can get built back into the actual devices that we purchase reduces the load on us to have to patch it after the fact. In many cases, you can't patch it after the fact, and the only way to do it is to get it into the design and development cycle of the actual automation products. There are benefits to the suppliers. By using the ISKI certification program, it gets a means of defining, updating, and approving security certifications. Global suppliers get an international security requirement, so it makes their products more accessible throughout the world. And then it addresses the critical infrastructure requirements. So if you buy a product globally that has the ISA Secure logo on it, you know what you're getting off the shelf. So, how to participate in ISA Secure, to become an ISKI member, to apply for ISKI accredited certification lab, or to the ISCI CRT lab program. Any of these questions can be answered. Any of these questions can be answered by Andre Restano, who is the Managing Director of ASCI. You see his contact information here, and it's going to be repeated again later so that you can get in touch with him. So if you have any questions in these areas, feel free to contact Andre. At this time, I'd like to turn it over to Graham Speak.
Thank you, Ed. Good morning, everybody. Okay, so I'll just continue on more in depth here. As both John and Ed said, the ISKI certification is tied very much into the ISA IEC 99, or as it's now called, the 62443 structure. So ISA 99 will become 62443 in the future, and that you'll be seeing that a lot more. So where the ISA Secure fits in, but for devices, we're sitting in the 62443-4 series, so the -1 and -2. And with ISCI, sometimes we are trailing ISA standards, and other times we're actually giving input. So the 62443-4-2 has taken a lot of the ISCI specifications that we produced and then looking to turn those into ISA IEC standards. So there's always back and forth between us and ISA and IEC. In terms of the systems, we're looking at the 62443-3 series, and certainly out of those, the -3 series or standard is the one that a lot of the work that we're doing with the certification ties in with. And we've also talked about life cycle. In one of the other ones, the 62443-2-4, which is the green box on that slide, which was a standard by WIB, that's moving into this structure, and a lot of that is talking about the life cycle of products. And that one should be out next year. I'm the editor of that standard. So a quick going over about the device certification. We did this to the last webinar, but basically it's got a number of different sections. So as we've said, we've got the CRT or robustness testing. So it's looking at the vulnerabilities in the networks and the devices in a number of the 4 layers of the OSI reference model. The functional security assessment, the FSA, this is looking at detected implementation errors and omissions. So, just looking at the functionality that we have in there and auditing what we say we've put in there. And then lastly, the software development security assurance. So, making sure that we have a development and maintenance processes in place. The company comes in and audits all those, and effectively making sure that as an organization, we've got a robust, secure software development process. And I think it doesn't matter what that process is, as long as it is robust and secure. So every vendor will have differentiating standards on this, but it's all got to be audited. In terms of embedded devices, it's anything that's running embedded software to monitor or control an industrial process. So it can be, things like a programmable controller, can be an intelligent electronic device, or a SCADA controller, an RTU. Each industry will have different things. As long as it's monitoring and controlling devices with embedded software, we're calling that an embedded device. So lots of different companies and different industries are looking at using ISCI, and it just depends on what you're looking for. And some of the things, and you'll see that there's some companies have got multiple devices certified. How much can you reuse? Well, a lot of it, like the overall software development security lifecycle, that will be the same, assuming using the same development lifecycle across all your products. You audit it once. Okay, you might re-audit it when we change the specifications, but basically, if you've got multiple devices, do that SDLC once, and then it flows down to the rest of the products. Obviously, things like the robustness testing has to be done on individual products. You can't share that one, as well as the functional security assessment. So we are trying to make sure that customers, the end user vendors, will reuse as much as they can to obviously keep the cost down and get the multiple devices through the process. And then we're looking at the system certification. So yes, we've had each individual device certified and we've got that process, but really nobody puts in a single device into their plant. It's part of a system. So what we're looking at now is getting the specifications for this system certification together. And again, one of the first ones was getting the SDLA done. So we've got to have companies who are producing devices in a secure manner over the whole life cycle of that product. you've got to look at the vulnerabilities in the system robustness testing. So very much like the CRT, this is going to look at doing penetration testing at all the entry points. So a vendor will submit their system, and it will have defined entry points to that system. This will test all of those. And it will be a combination of the CRT and other techniques, depending on what the whole system is. And then they will be looking at the functional security assessment. And it will be ensuring that fundamental security features are provided. So that won't be on an individual, that will be for the whole system, to make sure that the system has got a well implemented and designed in security requirements. So what is a system? I mean, a system can be a number of boxes, systems from one supplier. It could be hardware and components from several manufacturers integrated together. Probably when you think of anything that, or most systems that are given, put in the market by a vendor, will be a mix of hardware and software from different manufacturers. We all build, for instance, on, or most of us build on Microsoft operating systems, then put our software on top, then actually add in other pieces of software. So we are combining lots of different bits of hardware and software together. But also it could be an integrator bringing different components from different manufacturers all together. So some of these can be, a control system platform, a package control system. Might be a controller with a HMI. So we're leaving it open for the end user, for the vendor to put that forward to us to see what they want to actually have accredited. Again, with the SDLA, we're using some of the similar books and methodologies that John and Ed pushed out. So, the Microsoft Security Development Lifecycle. If people haven't got any previous knowledge of an SDL, this is really there's a couple of good books from Microsoft on this that are well worth reading. They're very easy reading, and it gives you good background understanding. We've talked about BSIM, but also other ones that we brought in were the IEC 61508, which is on functional safety, the IEC 15408, common criteria, and also the RTCA DO 178B, which was aviation. So we looked at all of these when we were putting our certification documents together and trying to get the best out of all of them, so we could put that in to give some good guidance to the supplier. And again, and when we're looking at the SDL phases, these are very similar to some of the ones that were brought up earlier by John. You've got to have an overall security management process. And then you've got to look at all the other phases of a design, from the specification, the architecture design, looking at a risk assessment, and I think looking at risks for where your products are and how you're doing it is very important. Making sure you have your detailed software design, security guidelines, all the way through down to testing and then the security response execution when you have a problem. All of these do get audited in our SDLA phase. Then looking at the security lifecycle assurance certification, what it means to suppliers and end users. So in terms of suppliers, I think only vendors can build in security. We need to build that into our products, and we need to then give it to an end user. An end user can't do it. You can add it on, but you can't have it built in. So it's very important that a supplier builds this in to every single product he designs. Sorry, some pop-ups come up on my box. We need an SDL to ensure that the security is built in and not added on. And if you have secure software, it will equate to a quality software. I think there's so many references you can look at to say that. I think that's what we've all got to bear in mind, that it will give us a better quality overall. Okay, and I think at that point I'm going to pass it on to Ed to give the end user perspective of the benefits of of this insurance and this certification. So over to you, Ed.
All right, thank you, Graham. As Graham mentioned, definitely the supplier benefits are what the end user is looking for. The ability to build in the security into their products, because from our perspective as an end user, the formal development cycle on security will allow asset owners to align with our process automation support plans, because we support our assets through a life cycle management, both the actual physical assets and the process automation system assets. We have a life cycle management, and it's driven by technology and the need to improve technology to deliver our products. So if we have that developed into our automation solutions, we can align with our asset lifecycle management and their software development asset lifecycle management. And if we know the phases that they're using in the SDLA, it helps us to provide troubleshooting and correction of problems with our install solutions, because if we see a symptom that we know could be occurring in a certain portion of the life cycle of the development of that software, we can get back to the automation supplier, and quickly we can both align with where that problem might be, they can find a solution, and we can get a solution back to us in a short notice. Then the automation solution provider can more clearly communicate the impact by phase when we suggest an improvement to a solution. So we come back and we say, you know, we need more of this or less of that, and we think that might impact you in this part of your development cycle. Let's talk about it and see what it'll take to get it to us, get that new solution to us. So it just allows us a better communication path when we both know the cycles it's gone through in developing the software. And as we said, there's benefits on both sides. It's being structured, auditable, and so forth. For the end user, it's easier to specify. We can say we need an ICS security compliance certification on the product, and we need it at a certain level in order to satisfy our needs in the field. And we can build that security requirement into our request for proposals. And it also reduces the time at the factory and site acceptance testing process, because again, we already know the development cycle and how that has been put into the product, so we know how to test and make sure that we're getting our security level that we need. And so it's a known security level out of the box. And on the supplier side, they evaluate it once, they get recognition for their effort. They get to show the ISA Secure logo, and they know that they've got security built in that meets the end user's requirements. It does become a product differentiator, and it should reduce the support cost, as we mentioned before, because both the asset owner and the supplier can communicate about the various phases that might be impacted by a symptom that they see in the field. And it does provide enhanced credibility. So in summary, the industry needs to demand the software security assurance because it's good for the overall industry, the combined suppliers and the asset owners. The supplier can achieve this by incorporating it into their development life cycle, and ISA Secure provides that mechanism to do that. And here's some examples of 4 products that have been put forth and have achieved the EDSA, which is the Embedded Device Security Assurance, at various levels. And there are 4 devices in the pipeline being evaluated right now. So with that, I want to open it up for questions.
So we'll take questions through the chat. Should be on your screen. So we have a question about the documentation planned for ISCI certification. John, you want to take that?
Yes. I can't see the question, though.
With IEC 61508 certification, a very detailed test report is available to provide individual evaluation of the results. What exactly is planned for documentation associated with ISCI certification to allow external experts to review the results? Okay.
Yeah, I see the question now too. Yeah, so a very similar documentation is available for ISA Secure as what would be followed for 61508. Basically, when a company goes through the assessment, there's a very detailed something called a security case that gets documented. That is all the documented evidence that a product has passed all the phases of testing and has been evaluated for the other areas, the functional security and the software development lifecycle. That information then gets summarized in a detailed report. That report is made available to the applicant. It's up to the applicant how they wish to share the report, which is very similar to the processes and practices that are used by 61508 certification bodies like TV and Exida and CIRA. Those reports usually do get shared by the vendors or applicants with their customers, and if they grant permission, those reports will also be made available through the certification body's website. The other document that gets produced is the actual certificate. That document is a public document, and that document will be provided by the applicant and also by the certification body.
Right, and we do have plans to post the certificates online. We have a couple other questions: the cost of certification and how long it takes to get a device certified.
Okay. I'm not seeing these, but I can answer it. If people could write their questions, send it to everyone, that would make it easier. Cost of certification for devices, it does vary depending a little bit on the complexity of the device, the number of interfaces, and the level that's being sought after, whether it's level 1, 2, or 3. But in general, it's the cost for certification runs somewhere between about $25,000 and about $50,000 or $60,000. But there is a fair amount of variation, so it really does depend on a few factors. That includes any of the fees that also need to be paid to any of the other third parties, the other parties involved. And the time it takes for certification also varies quite dramatically. That depends on a few factors, mostly the preparedness of the applicant. And on average, I'd say they're taking somewhere between 3 to 6 months. But there's particularly for the software development lifecycle phase, sometimes it can take quite a bit of time for the applicant to get together the required documentation and evidence. So so that process sometimes can take quite a while. But if the applicant's well prepared, then the process can be relatively quick. The actual time for the certification body is usually about a week for CRT testing, usually less than a week for the functional security assessment, about 3 days, and 1 to 2 weeks for the software development lifecycle assessment in terms of man hours spent on the project. But then there are often long gaps of time in between some of those phases, or while waiting for materials and evidence.
Okay, and then the next question is, explain the positioning of ISKI certification versus Achilles certification defined by WorldTech.
Yeah, that's a good question, because there is a distinct relationship between the two. We didn't have it in this webinar. I think we had an actual slide on that in our previous webinar that shows the linkage. But the linkage between the two is that the ISA Secure, as Graham said, has 3 parts. One part of the certification is communication robustness testing, or CRT testing. And for that, ISA and WorldTech reached an agreement a couple of years ago. I think there's a press release on the ISA Secure website that talks about this agreement, that the CRT specification was actually a harmonization between the WorldTech Achilles and ISA Secure. And what that resulted in is that the Achilles Level 2 certification specification is now equivalent to the ISA Secure CRT. So the Achilles satellite is one of the recognized tools used by ISA Secure labs, CRT labs. What that means is that the tests, the actual tests test cases that are produced by the Achilles satellite are compliant with the ISA Secure CRT requirements, and that's been verified by ISA Secure. So the linkage between ISA Secure and Achilles is at the CRT level of ISA Secure, and then the other layers of ISA Secure, FSA and SDSA, are essentially additional requirements that are required to gain ISA Secure certification, whereas Achilles communication certification is focused just on the CRT portion.
Okay, and then the next question, how would certification work for something like process historian and visualization?
I guess I'll take that one as well. At the moment, the certification programs available from ISA Secure are the device, embedded device, or EDSA, and soon to be released as system level certification. And also on the roadmap is to offer a standalone certification just for the software development process for an organization, or the SDLA. So something like a process historian or an HMI visualization would fall under a couple of different ways that could be addressed. One is if it's part of a system, a historian or an HMI, it could be evaluated as part of a system and as part of the new system security assurance program that will be coming out later this year. Or the software development process for the supplier of the historian or the visualization component could be certified through the future SDLA, Software Development Lifecycle Assurance, standalone certification.
Okay, so I'd like to wrap this up. Thank everybody for attending, and we'll send a link out to everyone with the recorded version of this posted online on our website. If there's any other questions, you've got our contact information. Thanks, everyone, for attending, and thanks, Graham, John, and Ed, for presenting.
You're welcome.
You're welcome.
Thank you.